All right, let's get into it. I'm Ghost.
And I'm Spectre.
Now, if you're here looking for a simple guide to find your next P4 duplicate, this is probably not going to be for you. We're here to do something different. We're going to help you level up, to totally rewire the way you think, and take you from being a pen tester who just finds vulnerabilities to a strategic operator who achieves objectives. And trust me, there is a world of difference between the two.
Yeah, look at it this way. See, pretty much anyone can run a scanner and find a hole in a wall. A bug bounty hunter, well, they get paid for pointing at that hole, writing up a nice little report about it. An operator slips right through that hole, maps out the entire building's blueprints, learns the guard schedules, finds the master key card, and then they live in the penthouse suite for 6 months without a single person ever knowing they were there. It is never, ever about the bug. It's about what that bug gets you. It's always about the mission.
Okay, let's really break this down, because this slide right here is the foundation for everything we're going to talk about. Over on the left, you've got the pen tester. Their whole goal is finding bugs, right? Their tempo is what we call smash and grab. Get in, find a critical, write the report, get that paycheck, and get out. Success is measured by how many reports you can stack up. But on the right, that's us, the operator. Our goal is objective completion. That could be anything from exfiltrating one specific database to gaining quiet persistence on a CEO's laptop. Our tempo, it's low and slow. I mean, we can spend weeks just watching and listening. And success for us? It's achieving that objective without the blue team ever even knowing we were there.
So here's the gauntlet we're going to run you through. These are the 5 phases of every single real-world operation. First up, digital stalking. Think of it as intel gathering on steroids. Next, picking the lock. That's exploitation, but with a real purpose. After that, the invisible man. This is all about C2, evasion, and not getting your ass caught. Phase 4 is living off the land. Post-exploit, moving around and owning the whole network. And finally, becoming the ghost. Exfil, cleanup, and leaving yourself a quiet little way back in. So yeah, buckle up.
Okay, phase 1, digital stalking. And look, I need to be crystal clear about this. 90% of a successful operation is won or lost right here, before you even think about sending a single malicious packet, before you even run a port scan. The information you gather in this phase dictates your entire attack path. Amateurs, they jump straight to exploitation. Professionals, we live and breathe recon.
Right. And reconnaissance, from our perspective, it's not just about finding subdomains, it's intelligence gathering. You're essentially building a complete dossier on the target. This covers their tech, their infrastructure, their software supply chain, and, this is the crucial part, their people. Every single piece of data is a potential thread you can pull on later. You know, an old developer blog post, a LinkedIn profile for a DevOps engineer, a leaked API key you find in a public GitHub repo. These are the little things that turn a supposedly impossible target into a total cakewalk. You're not looking for a vulnerability just yet. You're looking for the path that leads you to one.
All right, let's talk triage. This is your 15-minute drill when you first get a target. First thing, define scope. You have to know the boundaries so you don't accidentally pop some box that brings a whole world of federal attention down on you. Second, tech stack. You got to know what you're up against. A Node.js and GraphQL API running on AWS needs a completely different playbook than some legacy PHP monolith. Third and fourth, scans and discovery. This is your automated sweep, just looking for low-hanging fruit, live hosts, open ports, common endpoints. Fifth, quick wins. You check for the dumb stuff. Exposed Git configs, public S3 buckets, you'd be surprised. And finally, and this is the most important step, decide. All this initial data, it isn't the mission. It's the intel that helps you build a real attack strategy.
So let's talk about what happens when you get lazy. You know, when you just click run on your fancy, expensive, automated recon script and you trust its output without a single question. I'll tell you what happens. You get your ass handed to you. Which, conveniently, leads me to one of my favorite war stories.
We were on this red team engagement against a huge fintech company. I mean, this place was like Fort Knox. We spent a solid week running every tool in the book. Nothing. The junior guys on the team were about to write it up as no findings, and I told everyone to just stop scanning and start reading. So we went back, way back, to the company's developer blog from 2019. And in a single post, it mentions their new V3 API was a huge improvement over the old /v2/endpoints. Well, shit. No scanner had picked up a V2 subdomain because it wasn't in any of the public cert logs. So we manually pointed our tools at it, and it was a ghost town. No WAF, outdated libraries, and a beautiful, beautiful IDOR that let us pull every single customer transaction they had. Game over. The lesson here? Your tools are idiots. You have to be the human with the
And that story perfectly tees up the elite take here. A pen tester runs automation. An operator builds an intelligence profile. We start by asking a simple question. How does this business actually make money? Because that tells us where the crown jewels are. Then we start looking at the human element. We find their DevOps and SRE folks on LinkedIn, and then we pivot over to their GitHub accounts. We're not even looking for code vulnerabilities at this stage. We're looking at their commit history, their config file formats, their preferred coding patterns. It's all about building a psychological and technical profile of the people who built the system, and that's far more valuable than any port scan could ever be.
Okay, let's do a quick technical deep dive on your initial toolkit. Subfinder is your go-to for passive subdomain enumeration. It's crazy fast and stealthy. You pipe those results directly into HTTPX to see which of those hosts are actually live. Okay, now you've got a list of targets. You feed that list to Nabu for a quick port scan on the common web ports, 80, 443, 8080. While that's running, you use Wapalizer to figure out the tech stack. Then you kick off FUF for some content discovery with a small fast word list. Finally, you run a quick, non-intrusive nuclei scan with just the low-risk tags. Remember, the goal here isn't to find a critical. It's to build a map of the attack surface in under 30 minutes so you can start your real manual investigation.
All right, phase 2, picking the lock. So we're moving from intelligence into active exploitation. Look, any script kiddie can run Metasploit. A decent bug hunter can find a vanilla SQL injection. But an operator finds a foothold, any foothold, and turns it into a kingdom. We're not looking for bugs, we're looking for keys.
So let's start with our absolute bread and butter, the Insecure Direct Object Reference, or IDOR. OWASP has a new fancy name for it, Broken Object Level Authorization, or BOLA. But forget all that for a second. This is, hands down, the single most common and devastating vulnerability you'll find in modern APIs. It's simple. The server trusts you when you change an ID in a request, and it never bothers to check if you're actually authorized to see that other user's data. It's a P1, a critical finding, almost every single time.
The concept for finding an IDOR is dead simple. You just need 2 accounts. Log in as your attacker account, do something, and capture that request in a proxy like Burp. Look for any identifier that points to your user. Now you find the victim's ID. You go back to your attacker's request, you swap your ID for the victim's, and you send it. If you get the victim's data back while using the attacker's session, well, congratulations. The key here is systematic testing. If you find one, it's almost certain the same developer made the same damn mistake on every other endpoint in the API.
Now, if IDOR is the bread and butter, then server-side request forgery, or SSRF, is the holy grail, especially in the cloud. An SSRF is when you can trick the server into making a web request for you. If they don't bother to validate the URL you provide, you can tell it to fetch things from its own internal network. We're talking databases, admin panels, or the ultimate prize, the Cloud Metadata Service.
And this leads us right into another war story. Let's say you find a vulnerability that the dev team has already triaged as a P4, just an informational finding. It's a leaky API, and it's spitting out an internal hostname. A bug hunter would probably report it, get a thank you, maybe $50. But you're not a bug hunter. So what's the next move?
We found this exact scenario. A verbose error message was leaking internal Kubernetes service names. The client security team had marked it low risk, but for us, that info leak was a roadmap. We found a feature where you could import a profile picture from a URL, and we just pointed it at the internal hostname we discovered. It timed out, but our collaborator got a DNS lookup, blind SSRF. From there, we used it to hit the AWS metadata service, pull the IAM credentials, and within an hour, we had full access to their production S3 buckets. That P4 info leak, chained with a P3 blind SSRF, became a P1 critical compromise. That is the operator mindset. Low plus low can equal critical.
And this is the elite take. A pen tester is hunting for a remote code execution, an RCE. They find it, they report it, they're done. For an operator, finding that first vulnerability is just the start. An IDR is just as valuable to us. We'll use it to script and enumerate the entire user base just to find high-value targets. Right. The initial exploit isn't the goal, it's just the key to the first door. An operator doesn't just report that they found a key, they open the damn door, walk inside, and start looking for the key to the next door. The strategic goal is always deep access, not just some surface-level win.
Okay, let's do a quick technical deep dive on that classic SSRF to AWS credentials chain. Every single EC2 instance can talk to a special IP address, 169.254.169.254. This is the metadata service. So with an SSRF, you point your payload right there. Step 1 is you request IAM/security credentials/ to find the IAM role name. Let's just say it comes back as app server role. Okay, step 2, you request IAM/security credentials/ app server role. The response you get back will be a JSON object containing the access key ID, the secret access key, and a token. These are temporary AWS keys. Now, a common WAF bypass, if they're blocking that IP, is to use its IPv6 representation /CFFF169.254.69.254. Once you have those keys, you effectively become that server.
So, you've picked the lock. You're inside. A pen tester would plant a flag and start writing their report. For us, the operation has just begun. Welcome to Phase 3, the Invisible Man. The goal now is not just to be inside, but to stay inside and achieve your objectives without the blue team ever having a clue you were there. Getting caught is failure, period.
Evasion is really the core of this entire phase. It's a constant cat-and-mouse game against WAFs, EDRs, and all kinds of network monitoring. You can think of evasion as the art of making your malicious activity look like normal, boring, everyday traffic. It's all about understanding exactly how these security controls work and then finding the gaps in their logic to slip through.
So let me pose a tactical question for you. You found an IDR, and you want to exfiltrate data on, say, 1,000 users. But the API has a rate limit of 10 requests per minute. A simple loop is just going to get you blocked instantly and light up their dashboards like a Christmas tree. So how do you fly under the radar? The trick is, you don't brute force the control, you look for a flaw in its logic. And this brings us to a beautiful technical deep dive on evasion, abusing GraphQL batching. A lot of GraphQL APIs will let you send a whole array of queries in a single HTTP POST request. Now the rate limiter, if it's poorly configured, just sees one incoming request, but the GraphQL server on the back end goes ahead and executes all 100 queries you stuffed into that single request. You can exfiltrate data at 100 times the allowed rate, and the rate limiter is completely blind to it. You're using the application's own features against it, and that, my friends, is the most elegant form of evasion.
Time for a war story about getting it wrong. This was early in my career. We were on a long-term op, we'd popped a box, and we were using a pretty standard command and control framework, a C2. It was configured to beacon out every 60 seconds. The problem was, the pattern was just unnaturally perfect. A GET request every 60 seconds, right on the dot. It didn't look like human traffic at all. Some sharp blue teamer looking at egress logs for statistical anomalies saw our traffic sticking out like a sore thumb. They black-holed our IP, and just like that, the operation was over. We got burned because we were lazy and we were loud.
And that really brings us to the elite take. A pen tester uses a default Metasploit payload. If it gets caught by AV, hey, that's a finding. For us, that's mission failure. An operator's C2 is bespoke. We profile the target's normal network traffic first, and then we build our C2 to mimic it. We'll tunnel our commands over DNS-TXT records. Just think about it. Every single network allows DNS queries to function. We just hide our commands inside those legitimate-looking queries. Another great technique is domain fronting, where we route our C2 traffic through a trusted CDN, which makes it look like the compromised server is just talking to something like Google or Microsoft. The best C2 is the one that gets lost in all the noise.
Okay, so you're in and you're invisible. Welcome to Phase 4, Living Off the Land. This is where the real war actually begins. That initial machine you compromised, that's just your beachhead. Now the objective is to expand that tiny foothold until you have complete and total control. This phase is all about the patient, methodical takeover of an entire environment, turning one user account into domain admin, one web server into control of the entire cloud.
Let's walk through what we call the SaaS kill chain. It's a devastatingly effective modern playbook. It starts with a simple mistake. Some developer pushes a Slack token to a public repo. Now, for a bug hunter, that's a quick P3 report. For us, it's the front door key. With that token, we're inside their Slack, reading their channels. We're not looking for passwords. We're looking for the fabric of their operations, links to internal Jira boards. Once we pivot into Jira, we're hunting for developer tickets where someone got lazy and pasted a GitHub personal access token, and boom, now we have their code. All of it. We run a scanner over the entire Git history, and there it is, an AWS key from 3 years ago. In that entire chain, we didn't use a single exploit. We just followed a trail of misplaced secrets right through their trusted systems.
It's a question we always ask ourselves. You pop a box, you get access to a code repo. What's the next step? Where do you look for that one secret that just blows the whole operation wide open? Is it in the current code? The config files? Yeah, sometimes. But often, the real gold is buried somewhere else entirely.
This is a true story. We were deep inside a company's GitHub. We scanned the current head of every single branch. Nothing. But then we started digging, deep into the commit history. 3 years back, we found a commit from an intern. The commit message was just initial setup, and in that commit was an un.env.example file with real hard-coded AWS root keys. A senior dev must have caught it and removed it the next day, but in Git, as you know, nothing is ever truly gone. That key was still just sitting there in that old commit object. We tested it, and it was still active. They had never rotated it. One simple mistake from an intern 3 years ago gave us the keys to their entire kingdom. You always check the history.
And this perfectly illustrates the elite take on post-exploit. A pen tester finds that AWS key. They take a screenshot, they write up a report that says hard-coded AWS keys in Git history, and their job is done. For an operator, finding the key isn't the finding, it's the tool. The real work starts now. First, we use the keys to run AWS STS get caller identity, just to confirm what permissions we have. Then we start enumerating the high-value services. Can we list S2 buckets? Can we get into Parameter Store or Secrets Manager? Can we create a new IAM user for ourselves to establish quiet persistence? The key itself is worthless. The access it provides is the entire goal.
Now for a really nasty technical deep dive, dependency confusion. This is a supply chain attack. So a company has private software packages, something like @company/internal auth. Their build systems are often configured to check the public package repository like NPM first. So, as an attacker, you find the names of these internal packages. You then create a malicious package with the exact same name, and you publish it to the public NPM registry with a ridiculously high version number, like 99.9.9. The next time their build server runs npm install, the package manager sees 2 versions, chooses yours because of the higher version number, and then executes your malicious code inside their secure build environment. You've just achieved RCE without finding a single vulnerability in their own code. It's a nasty one.
All right, we've reached the final phase. You have control. You've achieved your objective. But you are not done. Amateurs get cocky here, and they get caught. An operator's job isn't finished until the data is securely exfiltrated, every single trace of your presence has been wiped, and you've left yourself a quiet, persistent way back in. The stakes are highest right before the end. This is how you become a ghost.
Okay, let's run through the operational teardown checklist. First, exfiltration. Don't do a massive data dump all at once. Use low and slow channels, like tunneling it out over DNS, a few kilobytes at a time, maybe over weeks. Next, you remove your tools. Anything you brought with you gets securely wiped. Don't just RM it, you need to overwrite it. Then, you clear your tracks. Every .bash history, every event log, gone. Fourth, fix the timestamps. Use touch to set the access and modification times of any files you touched back to exactly what they were. Make forensic analysis a complete nightmare for them. And fifth, persistence. This isn't some loud, obvious backdoor. It's a slightly modified cron job, a subtle config change, something that'll survive a reboot and won't be easily spotted. It's your insurance policy.
Let me tell you a war story that still gives me nightmares. It was a massive 6-month operation. We had full domain admin. We were absolute ghosts. We had staged all the target data, and we were literally one command away from starting the exfil. And then, it all went to hell. The blue team suddenly isolated our primary jump box. We had to burn everything. The entire operation was a complete bust. So what happened? A junior operator, during the cleanup phase, forgot to clear his bash history on one jump box. The sysadmin just happened to log in, typed history, and saw a list of commands that made his blood run cold. One damn .bash history file compromised an entire campaign because of one single moment of carelessness. OPSEC has to be absolute.
And that right there is the final, elite take. This slide says it all. For a pen tester, the mission ends when they click Submit on their report. For an operator, the mission is never truly over. We achieve the objective, we quietly exfiltrate the data, we meticulously erase every single footprint, and we always leave a way back in. That backdoor might not be used for years, but it's there. Because one operation is just a single phase in a much, much longer campaign. The goal is long-term, persistent access and information dominance. Submitting a report is easy. Becoming a ghost, that's the real art.
So, we've walked you through the entire kill chain, from digital stalking all the way to becoming a ghost.
You've seen the mindset, the tactics, and the tradecraft that separate the hunters from the operators. The path is laid out for you. The question you need to ask yourself now is, what do you want to be? Are you a hunter, happy chasing bounties and quick wins? Or are you an operator, patiently hunting for total dominance? The choice is yours.